Hi, Hashim here. So today we are going to simulate a propylene propane splitter. Well, in this tutorial, I'm also going to show you how to get columns going, custom columns going. So first of all, let us add the components, which are of course and propylene, propane and propylene. So this simulation will contain two columns, a stripper and a rectifier. The stripper is modeled as a reboiled absorber and contains 94 theoretical stages. The rectifier is a refluxed absorber containing 89 theoretical stages. The stripper contains two feed streams. One is the known stream, which is called feed, and the other is the bottoms from the rectifier. Propane is recovered from the stripper bottoms, and propene is taken off the top of the rectifier. Purity of the stripper bottom stream is 95%, while that of rectifier stream is 99%. We will be using Suave Redlick Gong property package, while the component list includes propane and propene, also known as propylene. So as you can see, we will first define our feed stream. This case will consist of a column divided into two tray sections, as I've said before, which is a reflex absorber as a rectifier and a rebound absorber as a stripper. So after our feed stream has been defined, we now go on to install our custom column. In order to do that, we click the custom column icon on object palette. The custom column feature will be used to build both columns in a single column environment. Click the Start with a blank sheet flow sheet button. The column appears in the PFD. Double-click the column in the PFD to open the column property view. Click the Design tab and select the Connections page. In the Inlet Streams group, enter stream feed as an external feed stream, making this stream accessible to the template environment. Enter the column environment by clicking the column environment button at the bottom of the column property view. In this example or simulation, you will need a total condenser, reboiler, and two tray sections. A tray section and a condenser will be used for the reflux absorber or rectifier. A reboiler and another tray section will be used for the reboiled absorber or stripper. We are now installing the stripper. We ought to provide names to our streams first. So this column has 94 ideal stages and a reboiler. You must make sure that you are within the column environment. Now you must provide the first stage pressure and the last stage pressure. This will define now we will install our reboiler. As usual, we name the streams and the reboiler itself. We now add our inlet And there you have it. The reboiler is installed. Now we install another tray section. This is our rectifier. We aptly name the streams. And now we will add the total condenser. Click on the total condenser icon to add the total condenser. Name all the streams as shown, or any name you like. Now we come back to our column environment. We add a specification, which is the column draw rate and the column reflux ratio. The column draw rate is 775 pound mole per hour of propene on a molar basis. We add the column draw rate after a mistake. I repeat, the column draw rate is 775 pound mole per hour. And now we add the column reflux ratio. The reflux ratio is simply 16.4. While adding the specification, you must notice the degree of freedom bar. It must be 0, or otherwise your column will not converge. And this holds true for all column environments. Now, as you can see, our column has converged without any delay. It has solved properly. You can open the workbook to check the material streams, their compositions, the energy streams, and such. Now you should reorganize your PFD so that the reboiler stage come below the condenser tray section, which is, if you have any knowledge of distillation columns, is the right way to do any sort of distillation. So make sure you reorganize your PFD so it is better understandable. It will not affect the results, but a disorganized PFD will be a bit difficult to understand. So reorganize it. Thank you for watching.